Alright, so here we are with 7.1, Understanding Volume. So our content objective for today is I can determine the volume of a right rectangular prism, right triangular prism, and right cylinder. Our language objective for today is I can write down and explain the meaning of volume as well as how to calculate it to someone else. So let's move on here. Okay, so the key term for today is obviously volume, which is the amount of space that an object occupies or takes up. So the amount of space that an object takes up. Now, the first question we're going to ask ourselves today, before we can even look at finding volume, is how do we find the... Yes, actually in this question we are definitely all about that base. Just, I guess, a different type of base. So that question again is how do we find the base? Well, to find our base of our 3D prism, we have to find the face, as we know from last unit, that shows the main shape of the prism. What do I mean by that? Well, when we look at a cylinder, the main shape is clearly a circle at the top and bottom here because it's a cylinder. So these are our bases because they're the circles, the shape of the prism. In a rectangular prism, well, when we look here, this is our base because it's the rectangle shape. It's the top and bottom. Now, if we did rotate it on its side, this could also be a base and a base as well, depending on how you look at it, okay? But it definitely is a rectangle because of the two bases. Same thing would go for if we had on here a triangular prism, right? In this wonderful drawing I have here, these clearly are the bases because they form the triangle. These sides, you wouldn't call this a rectangular prism. You look for the shapes here that really make what it is. So if it's a triangular prism, you're looking for the triangle. If it's a rectangular prism, you're looking for the rectangles. If it's a circular prism, which is actually a cylinder, you're looking for the circles. Okay, so that's always the basis of your 3D prisms. It's just the shape of the prism. And the other question is, how do I find the height? Well, the height is always the perpendicular distance between the two bases of a prism. So, for example, it's just the distance between the two bases. So, if I have, again, my cylinder, which is a wonderful drawing there, the height is just the distance between your two bases. So, base, height is right in between. Doesn't matter if it's this way, okay, because it's still, we have a circle here and a circle here. This is still always my height. In a triangular prism, if it was this way, right, we have a triangle here and a triangle here, so then our height is going to be this way. If that was changed around a bit and our prism looked like this, right, it would still be right here because we've got our triangle here and our triangle here. The height is just the distance between the two bases, that perpendicular line right here or here, here or here, here and here, here and here. That's always height. Okay? So now knowing these key things, let's go to our first question. So now we're going to look at how to calculate the volume of a prism. Well, there's not a complicated formula to this. It's simply just you need to multiply the area of the base by the height of the prism. Okay, so when we look at this, we're definitely all about that base first. Here our base is 35 centimeters squared and our height is 3 centimeters squared. It's given it to us already. So we just got to write down here our formula, which is volume equals the area of the base right there multiplied by the height, which is 3. So 35 centimeters squared times 3. Well, that gives us an answer of 105 centimeters. Now we got to make sure we know what unit we're working with here. So when we did surface area, centimeters times centimeters gave us centimeters squared. Well, this time we've got a centimeter squared times a centimeter. Well, 2 centimeters multiplied together before gave us squared. Now we've got a squared times a regular centimeter. Pretty much you can just add it up. So we have now centimeters cubed. Okay? So volume is always told in centimeters cubed. So our answer here is 105 centimeters cubed. This is also because if we were to break down area, that's kind of saying length and width, right? So that would have been centimeter times centimeter. So it would have looked like centimeters times centimeters times centimeters. So there's 1, 2, 3. That is centimeters cubed. Okay? So volume is always found in centimeters cubed. You don't want to use squared anymore. So let's look at another example. So example 2, we've got a triangular prism here. We've got a base of 12 centimeters squared and a height of 10 centimeters. Using our formula, I'd like you to solve for the volume of this triangular prism. So you can pause here and play when you're ready to watch. Okay, so for this one, my formula is already done for me. Volume is the area of the base times the height of the prism. Well, volume equals, the area of my base is 12 centimeters squared. Our height of our prism is 10 centimeters. So when we multiply those together, we get a total of 120 centimeters. And again, when we look at it over here, centimeters squared times a centimeter gives us centimeters cubed. So the answer is 120 centimeters cubed. Let's try another. So example 3 here. Now we got a cylinder, which is just wonderfully drawn by me, as you can see there. So once again, our volume to find this is going to be the area of the base times height. So you can pause it here and it'll play it when you want to see the solution. Okay, so our area of our base is 27 centimeters squared. Our height is 3 centimeters. When we multiply them together, we get a grand total of 135 centimeters. And again, when we look at it, centimeters squared times a centimeter gives us centimeters cubed. So our final answer is 135 centimeters cubed. Because we're rolling through this, let's try another one here. So here we've got a base, as you can see here, it's on its side. We've got a base of 40 centimeters squared and a height of 22 centimeters. So you can pause it here, and when you're ready, play for the solution. Okay, so again, our volume is always equal to the area of the base multiplied by height. Okay, so let's fill this in. Our area of our base is 40 centimeters squared, and our height is 22 centimeters. When we multiply those together, we get a grand total of 880 centimeters. And again, centimeters squared times a centimeter equals centimeters cubed. So our final answer is 880 centimeters cubed. Just for good luck, let's try one last one. Or I guess not. I think that's all we got for today. So the last thing I want you to highlight today, guys, is by changing the orientation of a 3D object, it doesn't affect its volume. Okay? So volume, again, is the amount of space an object takes up. And as you can see here, my fancy prism here, rotating around. So if it's right here, right now, looking at this way, the volume is the same as if it was rotating around upside down. Same would be if you had a cylinder like this. If you found the volume for it, it would be the exact same if you tipped the cylinder on its side, and it would be like this, identical. So changing the orientation does not affect its volume. Okay, it'll all be the same because by changing it this way, it'll still take up as much space as it did this way. Okay, it didn't magically shrink. So that's all for today's lesson. I'll see you all in class tomorrow, and have a good night.